Here we'll look at using the find function within Matlab. Now basically what the find function is going to do is we give it some logical test and it returns all the indices where that logical test is true. And it takes a number of different arguments that are optional that's going to give it different abilities. So if we look at using it in an example here, why would we want to use the find function? Let's look at this parabolic function that we made here and see what it looks like. So if I run this, if I want to plot, this is for a rocket trajectory, let's say. Oops, so I need to assign a value. I'm going to make a vector h, which is going to be my function little h evaluated at t. So big H will be a vector of all of my heights. That's what we want to look at, and we'll turn on the grid. Alright, so this is the trajectory of our rocket over time. Let's say that the y-axis is our height in meters. And x is our time in seconds. Okay, so this is all of our data here, and we want to see, for example, at what times is the rocket going to be above 50 meters. So the logical test we can look at, again, we want to use logical tests on a vector. We can see when is h, the height in meters, greater than 50. If I just run this, we see we get the logical test. I'm comparing a vector versus a scalar. So it's giving me 0 if the value of h is less than 50 and 1 if it's greater than 50. So we see it starts at 0, has a patch where it's 1, and then goes back to 0 because it's false again. So what I can use here is I can collect only the indices where it was true that h was greater than 50. And I can use the find command, find function to do that. So find, and my first argument here is the logical test, which is, as we just ran, only zeros and ones. So if I run it with find, what it gives me here is, again, just those indices where it was true. Let me clear this so we can just look at the find. So it's returning the indices of h where it was true that h was greater than 50. So it starts at index 515 and goes to 601. And I'll save this into a vector I'll call ind. Right, so ind just contains these numbers. And I'll suppress that. Alright, so if my question is, what are the times when it's above 50 meters, now I can use this index ind that I just created, if I now look at t, but just of those indices. This gives me, again, all the times it was greater than 50, because I'm looking at the vector t, but only the indices where the height was greater than 50. So we see that 3.94 about to 4.2 seconds, the rocket was above 50 meters. And also what I can do here, let me put a hold command, just to demonstrate how this is working. I'm going to overlay on my previous plot just these, or highlight really, the spots where it was over 50 meters. So we see we have the original plot, and now on top of that I'm plotting just the times it was over 50 meters. So we see that all of these points now in red are when the rocket was over 50 meters. So I'm kind of sub-selecting all of big H just where it was over 50 meters with this index. Alright, so there's more ways to use index. There's these optional commands that we can give it. Right, so I'm going to use that same logical test, or let me here, just for demonstration purposes, I want to see when does it cross 40 meters. At what time is that going to happen? So again, if I just use it the way I have been, where I'm going to find all the points that it's greater than 40. But what I want is, if the question is what's the first point it crossed 40 meters, I can put a second argument in that's going to return only a certain number of these samples. So if I put a 1 there, it's only going to return 1 and then stop that command. So we see when I just run 40,1, I get 177. So it's really just the first value that I got when I was using the find command before. So I'll call that point SP. So I'll also highlight this point where it crosses 40 meters, and this is only the first time it crosses 40 meters. Right, so we see that that point lines up. That first time it crosses 40 meters. Now it's not exactly 40 meters here, since I'm using a vector to do this, but it's the first time it's strictly greater than 40 meters as my estimate to the time it crossed 40 meters. Now finally I can use find with a third argument also, and this indicates the direction. So let's look at, if my question was, let's say, at what time does it fall below 10 meters? So it rises, it gets to its peak, and then starts falling down. I want to know when's the last time it's above 10 meters. So what I can use here is I want to find, I'm still looking again, it's greater than 10 meters. So I want to say the last time that that's true. So I have here all the times that it's greater than 10 meters here. I only want the last time that's true, so I can use this third argument here. I can specify, do I want to find the last one value or the first one value? So I can put in here last or first. So if we see here, if I use last, it gave me that point 877. And if I put that on my plot as well, then I'll call it EP. EP, and I can use a cyan marker here. Right, so again, what we see, that magenta was the first time it crossed 40 meters, then the red is all the times it was above 50 using the find command, and then using that last find command, I'm seeing the last time it was above 10 meters. So the last time it's above 10 meters when it's falling down is at 6.14 seconds, approximately, to 2 decimal places. And just to see the difference, if I put first here instead of last, it gives me the first time it crosses 10. Oops. Right, so we see that's actually at the start in this case. So let me modify this just a little bit. Let's look at the first time it crosses 20. We see we have the star versus if I put last. Now I have the other side of it when the time is 5.78 seconds over here on the other side. And now I can put here, in this example it doesn't necessarily make sense, but I don't have to put a 1 here. I could find what are the last 5 times that it's above 20 meters. And we see that this vector EP now has those 5 values, and applied here really close on top of each other, 5 of these stars for the last 5 times that was above 20 meters in this example. So again, to recap, we put in some logical test here. In this case, our logical test was h greater than 40, but we could use less than, equals to, not equals to, etc. In these examples. And then also with find, we can give it how many points to find that where that logical statement is true. And then the third argument is either first or last. We want to take the first n points where that's true, or the last n points where that's true. And by default, if we don't put this third argument in, it uses first. So really we only have to specify it if we want the last points, like we have in the last part of this example.